Okay, the recording has started. So as mentioned, okay, over the next few days, we will focus our attention on going through the questions from TYS paper 3, the structured paper. So today we shall start with 2013. So ensure that you have the 2013 paper 3 in front of you. All right. Now I'll begin. Now, the best way to get the benefit from these lessons is to really take down the answers, but really to think through the answers. If you miss taking down certain parts because it was too fast, please stop me to let me know. All right, you can unmute yourself or just type in the chat box to ask me to slow down. All right. Otherwise, you can also watch the video later on. Yes.
Mrs. So the chemistry exam is on 31st, not 27, right?
It's on 27th. 31st is physics, huh?
So 27 is chemistry.
Yes.
Okay.
All right. Now, so as mentioned, if you miss taking down anything, just let me know. Just stop me and let me know. All right. Now let's go to question 1 quickly. Now, the keyword here is clean air is a mixture of gases. Name 2 of these gases. The keyword here is clean air. All right. So you do not want any pollutants. So you are referring to natural clean air. What does it contain? So the major components of natural clean air would be nitrogen and oxygen. Nitrogen, 78%. Oxygen, 21% of air. Okay, and as well as argon. Argon is the next biggest component of clean air other than oxygen. Okay, so any 2 of these 3 answers will be all right. I will not accept other answers, okay, because you should name the main components of air. All right, next. Now, part B is no longer on air. Part B is really about cooling. On cooling, the gases in clean air may liquefy. So this word is important. It tells you that you're going from a gas to a liquid. Okay. Another word for liquefy in this case would be condense. The gases in clean air will condense. All right. So describe what happens to the spacing and the movement of the particles in these gases as they become liquids. Now, these are keywords here. Many of you would just give a one-liner when actually more detail is expected. When they say spacing here, they don't just mean the spacing decreases. So many of you just wrote the spacing between particles decreases as they become liquids. Give details. Even though there's only one dotted line, you can see my answer is very detailed because I know spacing means arrangement. They want you to talk about how the particles are arranged in a gas at the start and what does the arrangement become as it becomes a liquid. All right, so they are looking for arrangement. So as you can see, my answer changes to the spacing. The spacing between particles decreases and the arrangement changes from spaced far apart in an irregular manner to closely packed in an irregular manner. So what is this format of answering? You are going from the starting state, gas, to the ending state, liquid. You have to describe both to get 1 mark. All right, this is the level of details that you should provide in your answers. Don't leave the examiners to guess and fill in the blanks for you. They are trying to test whether you know arrangement of particles in a gas and liquid. So please make sure you give these details in your answers. Okay, so this was summarized yesterday when we went through kinetic particle theory. All right, next, the movement of particles. Okay, the movement of particles changes from moving in all directions at high speeds to sliding over one another easily. All right, Ken? So as you can see, the format of answering is very standard. It's going from something to something. Okay, so let's take this down while I admit the last 2 people into the waiting room. Now, KPT actually came out last year already, where they asked students to describe the changes in the arrangement and movement of particles as a solid melts. Okay, so the answers are always in this format. The arrangement of particles changes from blah, blah, blah to blah, blah, blah. The movement of particles changes from blah, blah, blah to blah, blah, blah. Okay, so learn this format of answering. So this concludes question 1. So question 1 of 2030. Okay, I'll just leave it on for the next 1 minute for you to take things down. So as you can see, even if I've marked your work and I've given you 1 mark or 2 marks out of 2, you really need to provide a lot more details in your answers. Okay, 1 hour, 15 minutes is sufficient for you to write details. Okay, details like the detailed descriptions of the arrangement and movement of particles in the gaseous and liquid states. Okay, so please make sure you give the details. Okay, moving on, let's go to question 2. Now, question 2 is one of those questions that you may freeze and be scared of because it's on salt preparation. Okay, but question 2 is really nothing to be scared of if you look and think through the question deeply. All right. Now, question 2. First, you need to fill in the blanks in the box, which I'm sure most of you can fill in. Okay, I think most of you know chemical formula by now. You know that sulfuric acid is H2SO4, calcium carbonate, CaCO3. Because calcium is Ca2 plus, carbonate, you got to remember, is CO3, 2 minus. So because we have a 2 plus ion and a 2 minus ion, the charges are balanced. They cancel each other out. Exactly. So the formula is just CaCO3. 1 Ca2 plus, 1 CO3 2 minus. Okay. In terms of the color of the solution with universal indicator, how do you tell the color? You have to look at whether the solution is acidic, alkaline, or neutral, right? So calcium chloride is neutral, therefore the color with universal indicator is green. Sulfuric acid is strongly acidic. You need to know that, so it's red. All right. Finally, I think the most difficult is this one. The alkaline solution of potassium carbonate should give a blue color. Now, how do I know that it's not purple? It's not purple because potassium carbonate is not a strong alkali. Okay, potassium carbonate happens to be a weak alkali. How do I know that? Well, by doing the TYS, you would have encountered questions like this in the MCQs in particular. You have encountered MCQs that told you that potassium carbonate as well as sodium carbonate is a weak alkali. Therefore, the color with universal indicator should be blue. Okay? Okay? So that's 5 marks. So as you can see, don't panic. Try to think through and fill in the blanks as best as you can. It's 5 marks just like that. It's quite easy to get. All right. And these 5 marks have nothing to do with salt prep yet. All right. It's just acids and bases as well as chemical formula. Now, the real salt prep comes in part B. Now, in part B, you are told when 2 of the substances in table 2.1, it's from the table above. Okay, you are not supposed to suggest some chemicals of your own. When 2 of the substances in table 2.1 are mixed together in solution, they form a precipitate of calcium carbonate. You are already told this is precipitation. It is precipitation because you are performing precipitation to produce insoluble calcium carbonate. This is precipitation. Now, precipitation for calcium carbonate, you must start off with a carbonate that's soluble. So that's potassium carbonate. And you must start off with another salt that contains calcium, calcium chloride. That's how you get the 2 substances. All right. You need to choose a carbonate that is soluble. Both must be soluble. So if you recall, this is the basis for precipitation. You start with 2 soluble starting materials to get an insoluble precipitate. So the two substances you choose to start with must be soluble in water. As you can see, both potassium carbonate and calcium chloride are soluble.
So,
Yes.
how do we know if it's a strong alkali?
How do you know if it's a strong alkali? So this comes from your studying, okay? So like potassium hydroxide, sodium hydroxide, these are strong alkalis.
Okay.
The rest are weak alkalis, like aqueous ammonia, weak alkali. Potassium carbonate, weak alkali. Okay?
Oh, okay. So anything that has hydroxide is strong alkali.
Sodium and potassium hydroxide. Okay? These are the common strong alkalis in the lab. All right, good question. Okay, so we are done with the precipitation. So let's recall precipitation. You must start with two soluble starting materials. Now, part 2 is the one that was a bit confusing for students in that year to answer. Most students didn't know what the three processes were. In reality, the three processes are easy to find, right? You know that calcium carbonate is a precipitate because the question says so. If it's a precipitate, that means it's a solid. So the first step is to filter to collect the calcium carbonate as the residue. All right. You need to say that it is the residue because it's a solid. It's a solid precipitate, therefore it's a residue. The next step is standard. Wash the calcium carbonate with a little cold distilled water, finally drying it between sheets of filter paper. That's it.
Will you get any mark if you just name the process?
Like filter, wash, dry.
Right, like evaporation to dryness, crystallization.
It must be the correct process, okay? So we do not crystallize it here because it's an insoluble solid. You will only crystallize it if it's a solid that's dissolved in water. But this one is not dissolved in water. Okay? Can? Now, so how do you know it doesn't dissolve in water? Two ways to know it. First, the question says precipitate. Precipitate means insoluble, doesn't dissolve. The next thing is, you can see in the table itself, they also told you that calcium carbonate is insoluble in water, so it will not be evaporation to dryness or crystallization. Okay. Now, as you can see, this question is 9 marks in total. These 9 marks are not difficult to score. Okay, you should be able to comfortably get 7 out of 9. Okay, so long as you think through it thoroughly, don't panic. Okay, so I'll leave it for another 30 seconds before we move on to the next question, which is actually more challenging. Okay, let's move on. Now, question 3 is challenging because it involves you interpreting the diagrams correctly, right? And you are given a key on the right-hand side telling you what each symbol represents. The black circles represent carbon atoms, white circles, oxygen atoms, and the small gray circle represents hydrogen atoms. All right. So this is important. You need to recognize this. So first, which one represents pure carbon dioxide? Carbon dioxide is CO2. So you must have 1 carbon atom, 2 oxygen atoms. So this one quite obvious. CO2 pure is found D, not the rest. Because only D contains CO2 pure. It's 100% CO2. There's no other compound or element in it. Pure oxygen. This is a difficulty. Okay, we have said it many times. When we say oxygen, pure oxygen, it doesn't exist as atoms. It's always diatomic. Oxygen, nitrogen, hydrogen, anything ending with gen, the element exists as a diatomic element, meaning you should have 2 oxygen atoms joined together as a O2 molecule. So you look, where do you find O2? Two oxygen bonded together. That's F. Okay. A mixture of compounds, that's C. Okay. So if you look at C, there is CO2. That's one compound. The other compound here is H2O. All right. How do you work out that CO2 and H2O? Use the key. Look at the atoms present inside. Okay. So CO2 and H2O are both compounds. They contain two or more elements chemically bonded together in a fixed ratio. Okay. So that's a mixture of compounds. Mixture of elements, B. How do I know that? I go back to the diagram. This is H2. Hydrogen is an element. This is O2. Oxygen is another element. All right, so B is a mixture of hydrogen and oxygen. Mixture of two elements. So far, okay. Now the last one is the hardest. And it's always going to be like this. Okay, you will have certain parts that are more challenging. It doesn't mean that you give up on doing it. In fact, if you want to do well, you have to try your best to attempt these parts. Because in a typical exam paper, there are certain parts that are more challenging, and part E is one of them. What are the products of burning ethanol in oxygen? Another way of saying burning ethanol in oxygen is just complete combustion, right? Burning is combustion. So complete combustion produces two things only. When you have complete combustion, there are only two products, which are CO2 and H2O, right? So if you are really lost in an exam, you don't even recognize that, oh my God, what is this all about? You think on what you have learned. Try to think back, recall, grab concepts from your brain. Okay? So burning ethanol and oxygen, burning, Mr. So has said before, burning means combustion. Combustion, you produce CO2 and H2O. So now look back at the diagrams. Which diagram contains CO2 and H2O? Answer is C. Okay? Now, most of you seem to have this misconception, wrong concept, that you can only use the letter once. That is not the case. All right? If they didn't tell you that each letter should be used only once, you can assume that the letters can be applied multiple times, so long as it's correct. All right? So long as it's correct. So don't make assumptions. Read the instructions, underline. That's what your pen or pencil is for. Okay? This is confirmed going to come out in some form. Right? If you look at your TYS for combined science, the first 15 marks actually is a one word or one letter answer. It may not be this question. It may not be elements, compounds, mixtures. All right. But you are going to have questions like these, where it's a 1 mark answer or one letter answer. Please don't make assumptions that each letter is used only once. It can be used multiple times, but read the instructions. Maybe the instructions will tell you each letter should be used only once. Then you know, okay, cannot use multiple times. If that's the instruction. Is that clear? Okay, read the instructions. I cannot stress this enough. Reading is very important. In fact, for 2013, right, the main examiner's comment is not chemistry. The main examiner's comment is students should learn to read instructions more carefully. And I agree. Students don't read instructions carefully. That's why they answer wrongly. If they read carefully, they will know how to answer. So read. Don't panic. Okay? So out of these 5, I would say the first 4 are quite straightforward. The last one is a bit more challenging. And that's why it's important to listen to all these details and get these details correct. Okay? All right, moving on. The next question is, looks simple, but it's hard. Okay? Now, this is a dot and cross diagram for calcium chloride, CaCl2. I'm sure you can draw this on your own. You should be able to draw this on your own. It's quite obvious that it's ionic bonding because you are even told it's ions, right? The difficulty is with part A. When calcium reacts with chlorine, neutral calcium atoms form calcium ions, each with a 2+ charge. Use figure 4.1 to explain how and why this change has taken place. The fact that they tell you how and why means that this is an extended, detailed answer they are looking for. They are not looking for simple things like the calcium atom loses 2 valence electrons, full stop. Most students in 2013 just wrote that. The calcium atom loses 2 valence electrons, full stop. Will that get you 3 marks? So now you got to think, if you are given a 3-mark question, are you going to write a one-liner, just 1 point? No, right? You're going to do your best to get as many points as you can. So now look at my answer. I started with electronic configuration, 2882 for the calcium atom. Why? Because I need to use the electronic configuration to then explain why it loses 2 valence electrons. And after losing 2 valence electrons, it becomes 288. So that it achieves a fully filled outermost electron shell. I stress on this word, electron shell, because many of you still didn't write the words correctly. The whole point about losing or gaining or sharing valence electrons is to achieve a fully filled outermost electron shell. All right, that is the goal, the reason why the change takes place. All right. And Mr. So even went on to talk about why is the charge 2+? The charge on the calcium ion is 2+, because it now has 18 electrons, which is less than the 20 protons in its nucleus. You lose 2 electrons, right? But you don't lose the proton. The proton is still 20. Because it's calcium, the proton number is 20. Okay, now let's look at this answer and take it down, please. Okay, even if you got 3 out of 3, I think you should take it down because this is really a detailed answer. It will leave no room for the examiners to question your answer. Okay, as you can see, for a 3-mark question, Mr. So will write a lot. Okay, I'm going to leave it for another 20 seconds. Once you are done, can you give me a thumbs up so that I know you are done copying?
Mr. So is the fully filled valence outermost electron shell, is it?
That's one important point that you must write, but you should write the entire paragraph starting from the start.
Okay.
Okay, whenever you are asked to explain formation of ions from atoms, this is how you should write for O level to ensure that you get 3 out of 3. Okay, so Leon, you're done. Okay, how about the rest? Once you're done, can you give me a thumbs up so that I know that I can move on? Okay, thanks, Madrina, Shakina, Ifala, yep. Okay, Sakina, okay. Okay, so as the remaining of you just copy, let me explain why do we have to write so much? Now, typically, there'll be questions like this in the O level, which will be 3 marks, 4 marks. In a typical 3-mark, 4-mark question, you will have like 4 or 5 marking points. You just need to hit 3 of them to get 3 marks. All right. Now, how do I know I need to state all the electronic configurations? Because if I look at figure 4.1, figure 4.1 shows you the electronic structure, right? It shows you how many electrons there are, how are they arranged into shells. So I know and I get the hint that I must talk about electronic configuration in my answer. All right. Next, this how and why. How refers to how many electrons it loses 2 valence electrons. Why refers to what is the purpose of losing 2 valence electrons. The purpose or the reason for losing 2 valence electrons is to achieve a fully filled valence or outermost electron shell. All right, so I know this is how I should structure my answer. And this is how you should structure your answer whenever you are asked about how ions are formed. Okay. Now, part B, I think is quite standard. Again, you can see my answer is really detailed. Okay, so this is about conducting electricity in the solid and molten states. Many people get confused with these 3 words, kinetic particle theory. They think that we need to talk about particles moving around. Not wrong, it's not wrong, but many students forget to name the particles. This is ionic compound, right? Calcium chloride is an ionic compound. The particles are called calcium ions, chloride ions. All right. So in the solid state, the calcium and chloride ions are held in fixed positions by strong electrostatic forces of attraction. The ions are not free to move and hence cannot conduct electricity. Okay, so this is where the kinetic particle theory comes in, because you know that in a solid state, your particles are in fixed positions. But you go one step further. I know what these particles are called. They are called ions. So the ions are in fixed positions because of the strong electrostatic forces of attraction. So they are not free to move. However, in the molten state, the ions are now free to move as the strong electrostatic forces of attraction have been overcome. Okay, so it can conduct electricity when molten. Okay, so this one is, I think, something you have already encountered before. You should be familiar with it to some extent. Just don't get confused with kinetic particle theory. Don't panic just because of that. All right, part C. Write the ionic equation for the formation of the ions in calcium chloride solution. This is very poorly done. The examiners also said very poorly done in 2013. Why? Never read. Write the ionic equation for formation of ions there. You form the ions, meaning the ions are produced, right? If the ions are produced, the ions should be on the right-hand side of the equation. So many of you got the order the other way around. All right. Ions are produced, they are formed. So they should be on the right side of the equation. Okay. So you can see basically it's just CaCl2 becoming Ca2 plus and 2Cl minus. It's just breaking up into the individual ions. Okay. And that makes sense because you know that when you dissolve calcium chloride in water, you get the ions and the ions are free to move. And that's why when it's in aqueous solution, it will also conduct electricity. Okay. So big mistake that year, many students got the order the other way around, like they swapped the order, which is not correct. Okay. Now, the good news is after question 4, question 5 was very straightforward. So question 5, I'm just going to go very quickly through it. I think most of you who handed in the paper for me to mark, most of you got question 5 correct as well, right? So I'm just going to move on to question 5.
Teacher, how do you do the equation?
The
Yeah.
equation, basically you start off with the CaCl2, the compound. Then when you dissolve in solution, in water, it breaks up into the ions. How do you know which are the ions? It's in the question, right? There's Ca2 plus, then there's Cl minus. But Cl minus got how many of it? Got 2, right? So it's 2 Cl minus. That's how you get the equation. Okay, 1 Ca2 plus, 2 Cl minus. Okay, so all ionic compounds will behave like this. When you dissolve it in solution, it will break up, dissociate into ions. Oh, one last thing. If the question says state symbols are not required, please don't write it in. Okay, I mean, I will minus your marks if you write it in correctly. But what the danger is that if you write it wrongly, like the state symbols are wrong, then you leave yourself open to being questioned by the examiners. Should they give you 2 out of 2? Okay, so try not to write state symbols if they wrote their state symbols are not required, which they did, right? Okay. Ken, so let's move to question 5. I'm just going to show the answers quickly for part A part 1 and part 2. I think it's quite straightforward. Okay. Most of you realize that the MR is just add everything up correctly. Please take note. You must take the larger number in the periodic table. What on earth does Mr. So mean? If you go look for nitrogen, for example, you will have this in the periodic table, right? So do you take 14 or do you take 7? 7 is the proton number, how many protons it has, how many electrons it has. But over here, I'm not interested in 7. I'm interested in the atomic mass, which is 14. Okay, so please take the larger number in the periodic table. Next, for combined science, very often to also help you, they may also give you the atomic masses on top. So just notice the atomic masses are given to you already. So don't sub wrongly, do it correctly. Okay. Now to calculate mole per dm cube is very straightforward. Take the grams per dm cube, divide by the MR. So in this case, 126 grams per dm cube, divide by the MR 63, which is 2 moles per dm cube. Now, part B, very straightforward. It's just a series of mole ratio calculations, right? So really, you just need to write a mole ratio correctly, which is 2:1. 2 nitric acid is to 1 magnesium carbonate. So if you have 1 mole of nitric acid, then you should have 0.5 moles of magnesium carbonate for B part 1. B part 2 is similar, same mole ratio, just that you need to now calculate number of moles of nitric acid, which gives you 5 moles. All right. Finally, what's the concentration in moles per dm cube? Okay, to just take the number of moles, 1 mole divided by the volume 2, that gives you the 0.5 mole per dm cube. So as you can see, this entire question is just converting to mole ratio, then use the formula triangles to find the answer. What formula triangle do I really need for this question? NCV. I know it's NCV because it's a solution. Solutions have concentrations. All right. So question 5, I don't think is very difficult. Most of you actually got the entire question correct. Just make sure that in the exam, please, if you use calculator, be more careful with it. Don't make careless mistakes when punching the calculator. All right. Now, question 6.
Teacher, I want coffee finish.
Oh, sorry.
Thank you. Yeah, I'm done.
Okay, thank you. Okay. Now, moving on to question 6. Now, question 6 is QA, obviously. You recognize all these flowcharts questions by now. Okay. Now, for QA, we always start from gases. So we will start with L, because L is the simplest. It's a gas, right? It's a gas that turns damp red litmus paper blue. Red litmus paper turning blue. So this is ammonia gas. All right. So after the gases are done, we will look at colors. Now, the colors here are important. Even though the solutions are colorless, you have many examples of litmus paper being used. So you think back to Sec 2 when you first learned litmus paper. Litmus paper is used to tell you whether something is acid or alkali, right? So G, for example, it's a solution that turns damn red litmus paper blue, meaning G must be some alkali. Only alkalis will turn red litmus paper blue. Similarly, H turns blue litmus paper red. It turns red. H is some acid. Right? So you got to think now, what acid is it? What acid could it be? You have only learned hydrochloric acid, nitric acid, sulfuric acid, right? So now you're going to ask yourself, which acid is this? Okay. How do you narrow down which acid it is? You have to look at the rest of the flow chart. Okay. So now let's look. All right. What other things are given to us in the question? I'm given things like barium nitrate. Barium nitrate is a test for sulfate ions. That's why the white precipitate K is barium sulfate. All right. So now you work backwards. What is J then? J must contain sulfate, right? If not, there wouldn't be sulfate later on when you add barium nitrate. Then what else could J be? Is J a metal sulfate? But let's look. It produces ammonia gas, you know, when you warmed it with sodium hydroxide. Producing ammonia after you warm it with sodium hydroxide, this is ammonium sulfate. Only ammonium compounds will do that. Ammonium compounds react with NaOH to form ammonia gas. Which gives us now the conclusion, G and H must be aqueous ammonia and sulfuric acid respectively. Because only aqueous ammonia will give you ammonium compound as the salt. Only sulfuric acid will give you sulfate in the salt. Okay, so the difficulty with this question is knowing that aqueous ammonia is an alkali and aqueous ammonia will give you ammonium salts after it reacts with acids. Okay, so you can see that L is ammonia gas, K is barium sulfate, J is ammonium sulfate, H is sulfuric acid, and G, aqueous ammonia. So therein comes the confusion. Some of you still like to write ammonium hydroxide instead of aqueous ammonia. Is that okay? The answer is yes, it's okay. Having said that, I think I've explained to you all before, you will not see ammonium hydroxide, these two words, in your test paper. They will not use it in the question. They expect you to know that aqueous ammonia is an alkali that will give hydroxide ions when dissolved in water. So you must still be familiar with aqueous ammonia. Even if you write ammonium hydroxide, you need to know that ammonium hydroxide and aqueous ammonia, they are the same thing. They are alkalis. All right, writing the equation, I've chosen to write this equation. As you can see, this is how you write the neutralization involving aqueous ammonia. One unique thing is you realize that it's just ammonia, aqueous ammonia plus the acid giving you the salt. There's no water. Not that water is not produced. It is just that when you write equations involving aqueous ammonia, there is no need to put the water on the right-hand side. It already balances. Okay. All right, so that's question 6. Okay, question 6 was not poorly done. In 2013, the examiners felt that most students understood question 6, but most students didn't write G correctly. They could not get aqueous ammonia, okay, because they have forgotten that aqueous ammonia is an alkali. So please remember, aqueous ammonia is an alkali, commonly used in the lab. You have used it many, many times for QA. Okay. Now, question 7, there's some graph plotting involved. I'm not going to go through the graph plotting per se, I just want to go through 7A and 7B quickly. The graph plotting, I shall leave it to you to do it yourself. It's just plotting points and drawing a curve. All right, let's go to question 7. Now, I think 7A is quite all right. Most of you knew the test for oxygen gas is to insert a glowing splint into the mouth of the test tube. And if it's oxygen, the gas should relight the glowing splint. All right, now 7B is the problem. Most of you, virtually everyone knew is the gas stream. But you need to label that is the gas stream. If you don't label, we don't assume that it's a gas stream, right? So labeling is very important. After drawing any diagram, always label the apparatus in the diagram, gas stream, stopwatch. Why you need stopwatch? It says every few seconds, you know. How would you measure every few seconds? The only way is to use a stopwatch, okay? Now moving on, okay, I think the gas stream is not very difficult to draw. The stopwatch is not really very difficult to draw. You don't have to draw a very artistic one. As you can see, my drawing is not very artistic either. Okay, so I said I'll skip the graph. Okay, please draw the graph yourself and draw a curve of best fit. Okay, now, this is something important. Whenever we say line of best fit in science, it may not be a straight line. It need not be a straight line. Please take note. All right, it need not be a straight line. Especially in this case, it's not a straight line. It's actually a curve. So please just be mindful. Now, part 2. Why did we not take further measurements after 220 seconds? Because the reaction has stopped due to all the H2O2 being used up and no more oxygen gas is produced. Okay. Now I'm going to admit Tan Zhe now because he told me just now that he had tuition, so it just ended. All right. Now, please take note, my answers are quite detailed. I don't just say that the reaction has stopped. I give the reason why the reaction has stopped due to all the hydrogen peroxide being used up and therefore no more gas is produced. Okay. Now, part 3, I shall leave it to you to read the graph yourself after you have plotted it. Part 4, again, I shall leave it to you to do it yourself. Just take note, average speed is equals to the volume of gas produced in that duration, 100 seconds, divide by the time taken, which is 100. Okay. So please take down the formula for average speed if you didn't know the formula for average speed of the reaction. Okay. All right, now moving on to section B. Now, section B is where you really need to leave enough time. So on Thursday, please keep an eye out for the clock in front. To do section B properly, you need something like 25 minutes or even 30 minutes. I will recommend 30 minutes. So please, when you go into the exam, once you see the clock in front hit 3:15, 1515, 3:15, you must move on to section B because you need 30 minutes to do it properly. All right. Your exam starts at 2:30. All right. And it ends at 3:45. So if you work backwards, you really need to give yourself about 30 minutes to do section B properly. And therefore, you need to start doing section B at 3:15. Now, question 8 is entirely organic chem. You can tell because it says that organic compounds are placed in a homologous series, right? Give 2 general properties of a homologous series. write the general formula for the homologous series of alkanes, name and write the chemical formula for the first member of the alkanes. You can see that this is 5 marks. It is really not difficult if you have studied organic chem, right? There's nothing difficult about this, okay? Then part B, it is entirely about addition polymerization of ethene, all right? So again, if you have studied addition polymerization, gone through the summary, you know how to describe addition polymerization, you should be fine. So let's look at the answers. So let's look at 8A first. Okay, it's about the homologous series itself. So members of a homologous series, what properties do they have? They have the same general formula, similar chemical properties due to the same functional group. They show a gradual trend in their physical properties as the number of carbon atoms increases. And finally, the members also differ from each other by a CH2 group. All right, so these are the things that we went through in our organic chemistry summary. Next, writing the general formula for the homologous series of alkanes, CnH2n plus 2. And finally, part 3, the chemical formula and the name of the first member of the alkanes. First member of alkanes is methane, CH4. All right, so the first 5 marks, I think we should not lose it at all. Okay, it's a matter of studying organic chem. Now I'm just going to scroll slightly down. Now B part 1 is slightly more challenging because you are told in B part 1 to use the structural formula of ethene to explain how it can form addition polymers. They are not asking you to draw polyethene. They are asking you to use the structural formula of ethene, the starting monomer. So you must first draw ethene. Ethene has the carbon-carbon double bond because it's an alkene, right? So why can it form addition polymers? Because, so we mentioned during addition polymerization summary that day on Friday, it undergoes addition polymerization as it contains a carbon-carbon double bond, which makes it unsaturated, right? So the carbon-carbon double bond breaks during the addition reaction to join with other monomers to form a single large polymer. And that's how you get 3 marks.
Mr. So.
What? Yes?
So it is standard that only those what is it called? What is this thing called?
Ethene?
Those
Unsaturated?
organic chem. I don't know. Whatever this thing is called. Only if they have carbon
double bonds.
Yes, they can go through polymerization.
Yes. So
only
all molecules with a carbon-carbon double bond can undergo addition polymerization.
Okay, thank you.
Okay. And the main reason is because the carbon-carbon double bond, which is the functional group of alkenes, breaks in order to join with other monomers to form a single large polymer. Single polymer because it's addition. Okay. And of course, the equation is something that you probably know how to write. Okay, so the examiner's comment for the equation in B part 2, the examiners said that most candidates, most students could write. But where is the careless mistake? The N on the left. Most people remembered the N and the brackets on the right-hand side, but most people didn't realize that you needed to put an N in an equation. You need to put the N on the left-hand side as well. So the N was a common careless mistake because it was left out. Okay. Now, before we move on to question 9, as you can see, this organic chem question is like, it's not difficult at all, right? This 10 marks, probably you can easily get 7 or 8 out of 10. Okay. So I hope this really shows you the importance of studying organic chem well. Okay, when you study organic chem well and you're able to do it well, you can get marks quite easily if your grasp of the content is good. So what we went through for organic chem, homologous series, okay, general formula, functional group, the reactions like addition, substitution, oxidation must be learned. We also went through things like processes like fermentation, addition, polymerization, as well as cracking, as well as fractional distillation of crude oil. We have gone through all these processes a number of times in class. How do you write and describe these processes? If you are still lost, it's time to go back to the consults and revision part of our OneNote to learn from it. Okay. Now, before we move on also, this is ethene. Is ethene the second member of the alkene homologous series, or is it the first member? So this is the trick. Most students seem to think that, oh, it must be the second member because got 2 carbon atoms, right? But now you think about it. Do you really have a 1 carbon alkene? What have you learned about alkenes? Alkenes must have a carbon, carbon, double bond. Carbon, 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 2 carbons, right? Must be the minimum. You cannot have a 1 carbon alkene because it must have a carbon-carbon double bond as its functional group. You must have a minimum of 2 carbon atoms in an alkene. And this is the reason why ethene is the first member of the alkenes homologous series. Another way of saying this is that it is the smallest alkene. Can you please take this down? Ethene is the first alkene, first member of the alkene homologous series. So if ethene is the first member, because you need to have 2 carbon atoms minimum in an alkene, because the functional group is a carbon-carbon double bond. If ethene is the first member, then what is the second member? So the second member of alkene has how many carbon atoms? Is it still 2? No, right? If the first member got 2 carbon atoms, the second member must have 3. When you have 3 carbon atoms, please make sure you know that there's only 1 double bond. The other bond is a single bond. Okay, so we have gone through this before. Make sure you fill in the hydrogen atoms correctly. Ensure that every single carbon atom has 4 lines, 4 bonds around itself. So this is a common trick. Can you please put some stars next to this? You need to know what is the first member of the alkenes, what is the second member of the alkenes. So of course, the second member of the alkenes has 3 carbon atoms. So this is called propene. Okay, propene. So the first member is ethene. The second member is propene because it has 3 carbon atoms. So the prefix is pro. So I shall leave it as this for a while so that you can copy down first. Okay, once you're done copying, just give me a thumbs up so that I can move on to question number 9.
Is it so?
Yes.
The third member is butene. Right?
Yes.
So basically, those that has more than those that has 2 or more can be considered as an, what's this thing called again?
Alkene.
Ah, yes.
No, it must have carbon double bond.
Oh, okay.
Double bond. Okay, between carbon. Okay, so Shami, you must look at the bonds to see whether there's a carbon-carbon double bond. If it's a carbon-carbon double bond, then of course it's an alkene. Must be carbon-carbon, not some other kinds of elements. Okay, good question. Okay. Okay, are we done? If you're done, can you give me a thumbs up so I know you're done? So don't be tricked so easily by this first, second member nomenclature. Make sure you know what's the first member and second member, okay? So alkanes, no problem. Alkanes, the first member is the 1 carbon alkane. But alkenes, problem. The first member is already 2 carbon atoms because the functional group is a carbon-carbon double bond. Okay, I'm going to zoom out in case you have not copied question 8. Can copy first. Now, question 9, I think it's not very difficult. Okay, most of you probably get the idea because a lot of it has to do with just explaining what's the meaning of exothermic, what's the meaning of redox, and so on. So I think that one, most of you get the idea. Okay, but let's go through how you will write question 9 once you're done with question 8. Okay. So let's move on to question number 9. So question number 9, you are given a particular reaction. The equation, the ionic equation is given to you already. All right. So it involves Al3 plus 3K forming 3K plus Al. So the ionic equation is given to you. So as you can see, the first part is just defining what is exothermic. I think most of you know exothermic reactions are reactions that releases or gives out heat energy to the surroundings. You must write into the surroundings. Okay. You have to include this key phrase, to the surroundings. Okay, whenever you define the word exothermic. Next, how do you define redox? The best way to define redox is to identify what substance is reduced, what substance is oxidized. So as you can see in this reaction, Al3 plus is reduced as the oxidation state of aluminium decreases from +3 in Al3 plus to 0 in Al. So recall, reduction is when the oxidation state of the element decreases. And recall the rules involved in oxidation state. Okay, one important rule. The oxidation state of an element is always 0. So Al at the end. Al is an element, so the oxidation state is 0. The next important rule, the charge on the simple ion tells you the oxidation state. So Al3 plus, 3 plus is the charge. So the oxidation state of aluminium in Al3 plus is +3. Okay, so in contrast, potassium is oxidized as the oxidation state of potassium increases from 0 in K to +1 in K plus. Same rules as just now. Hence, this reaction is redox because it involves both reduction and oxidation. So I think the last sentence is the one that many of you didn't write. So can you please take note? Redox, as the name suggests, involves both oxidation and reduction. Next, explain why it was essential that Wöhler kept water away from his chemicals. Obviously, essential means must. Why must you keep water away? That means that water and something inside the reaction must react quite violently. So if you think back to what you have learned, potassium, sodium, these are group 1. Group 1 elements are very reactive. So potassium is a highly reactive metal that reacts very violently with water. That's part 2. Okay. Then part 3, I think many of you got the idea, but you didn't answer directly, yeah? Okay. Explain why he used the dangerous and expensive potassium to prepare aluminium rather than the safe and cheaper copper. Obviously, you need to compare. The answer must be the difference. What's the difference between potassium and copper? Maybe the reactivity, right? So it's quite clear that this reaction is a displacement reaction. Potassium metal is displacing aluminium from its compound. So it's all about displacement. So now you're going to talk about reactivity of the metals. Potassium is more reactive than aluminium, so it can displace aluminium from its compound. Whereas copper is very unreactive. Copper is less reactive than aluminium, so it cannot displace aluminium from its compound. Okay, and this gives you 6 marks. Okay, the actual mole concept, I think it's quite straightforward. Most of you got it. Okay. So part B, I think most of you could do it correctly. So please ensure that you can do the mole concept. Okay, so I'm just going to leave this on for a while so they can take this down quickly. Okay, so that concludes question 9. Question 9 is about metals, redox, as well as mole concept. Okay, I'm just going to give you 2 minutes to take it down. Okay, 30 more seconds, just take it down. Okay, for those of you who have done it, as you can see, it's a matter of just doing corrections, adding to your answers. Okay, the way to succeed in section B is to give yourself enough time to write answers that are detailed for the parts that require more marks. All right. Now, the difference between 2013 and now is that now your section B comes with lines or spaces to do calculations, right? Okay, but the question style is still the same. Okay. Now, question 10 is not difficult. Most of you know how to do it. It is just that the way you answer, again, lacks details. So let's look at 10A. 10A, right, most of you know the answer. In fact, you all don't even know why the examiner want to ask something so simple. Huh? Why ask whether sodium is in which group, which period? So easy, right? But they want to test. always think from the perspective of an examiner. What are they trying to test you on? They are testing you on whether you know the relationship between group and valence electrons, period, and the number of filled electron shells. So first, you should always start off by saying the sodium atom's electronic configuration is 281. Many of you didn't even give this. If you didn't write 281, do you expect the examiner to know and fill in the blanks for you? Next, after writing 281, it's quite obvious it's from group 1 because we know that the number of valence electrons tells you the group number. It is from period 3 because the number of filled electron shells tells you the period. Importantly, filled electron shells doesn't mean fully filled. So sodium atom has 3 filled electron shells. Even though the valence shell is not fully filled, it still counts as a filled shell. Next, part B, please don't stun. It's 5 marks, sure. But actually, the answer is really straightforward as well. First, you need to know what is the element of proton number 12. Sodium and the element of proton number 12 have similar chemical reactions. So you should go to the periodic table. You should look. What is proton number 12? Proton number 12 is magnesium. Both sodium and magnesium can react with water to form the metal hydroxide and hydrogen gas. So give the equation with state symbols. That's one reaction, right? This is the first reaction. This is reaction 1. Plus the equation. This one 4 marks already. But you look at the question, they want you to describe 2 reactions. So what is the second reaction? Instead of reacting with water, they also react with acid, right? Both sodium and magnesium react with acids to form a salt and hydrogen gas. Okay, so this is testing you on metals. Okay, so let's take down 10B quickly.
Sure. In exam, I also need to write down the equation, right?
For one of the reactions you have described.
No, for B, I say B. I cannot just state what am I going to. I also need to write the
Equation?
Yeah.
You have to, because part B, they requested that.
Oh.
Write a chemical equation for one of the reactions you have described. Now, to be really honest, this question, right, is tricky lah. It's tricky not because of content, and the content is easy. You can study the content easily. It's tricky because most students, they don't realize that in one part, you may have many subparts to answer. Actually, this question is hard because you look at the question, you need to describe 2 reactions. That's one part to answer already. Then you're going to write a chemical equation for one of the reactions. That's another part to answer. So most students don't realize that there are multiple parts. So can you please have a habit? Use your pen to tick on the question once it's done. Make sure you really tick off every single question. If you are lost, right, look at the question words. Words like describe, explain, include, write. Make sure you tick on every question to ensure that you have answered every part. 10C, right, sadly, it's easy but difficult. What do I mean? Again, details. 10C, look at my answer versus your answer. Most of you realize that proton number 10 is neon. You just go to the periodic table, can find, right? The smaller number is the proton number. Proton number 10 is neon. Most of you realize that. But many of you, again, didn't provide the electronic structure. They already said, right, use their electronic structures to explain the difference. If you don't even write 281 and 28, then we will lose the mark. Right, next. It is unreactive and stable as it has a fully filled outermost electron shell. That's not it. You should go on to say, therefore, it will not lose, gain, or share valence electrons with other elements. That's what you have learned, right? Group 0 noble gases are stable because they already have a fully filled outermost electron shell. So they will not lose, gain, or share valence electrons with other elements. That's why they are unreactive. Okay, so you can see my 3 marks versus your 3 mark answer. My 3 marks answer, I try to be as detailed as possible. I always tell myself this when I go into an exam. I have one shot at this exam. I'm going to do the best I can. It doesn't matter if I make mistakes, but I'm going to do my best. I will write everything I know that is relevant. So you should have that policy as well. Okay, if you have studied and you know the content, write all the details in. Of course, within a time limit, make sure you manage your time. Okay, now before we go for the next for a break, okay, let's go through a few MCQs as well. All right, once we are done copying. Once you're done copying, can you give me a thumbs up so then we're done? Because I know there's quite a lot to copy. Okay, but again, if you missed any copying out anything, okay, you missed out on the copying, you can always go to our OneNote. It's under TYS. This is 2013 paper 3. Okay. Okay. So let's go to the MCQs now. All right. So let's turn to paper 1, the MCQs. Now I won't go through every question. I'm going to start with question 22. All right. So I will move to the MCQs now. All right. Now this is question 2 or question 22. Okay. Now this one, right, the answer is actually D. But let's go through why. So let's read carefully. A white crystalline solid X is heated with aqueous sodium hydroxide and aluminium. A piece of red litmus paper remains red. All right, while the mixture is heated for several minutes. This was very poorly done in 2013 because most students assumed if red litmus paper remains red, it must be acidic, right? Really? Acidic means what? If the gas is acidic, the blue litmus paper turns red. Or if it's alkaline, the red litmus paper turns blue. But if the litmus paper never changed color, same color, litmus didn't change color, does it really mean that it's acidic or alkaline? If it didn't change color, what can you conclude from it? The answer is you can't conclude anything. Maybe there is no gas. That's also a possibility, right? If there's no gas produced, of course the litmus paper won't change color, right? So you cannot say that because it's red, therefore it's acidic. Wrong. Maybe there's no gas in the first place. Similarly, you can't say it's acidic. X is not acidic. You can't conclude that way. All right? And even worse, you can't conclude that X is magnesium. You have not learned anything like this before, right? You have not learned a test for magnesium. But you can definitely conclude that X is not ammonium chloride because If X is ammonium chloride, you heat it with sodium hydroxide. Sodium hydroxide is a base. Base plus ammonium compound gives you ammonia gas. Over here, we already say maybe there's no gas, you know. If there's ammonia gas, then the red litmus paper should turn blue. So D is the answer. It's definitely not ammonium chloride because you don't get any ammonia gas. Okay? So that's question 22 in your book. Now let's go to question 24. This question is always tricky when it comes out. Not because it's very hard, but because of the way you are doing it is wrong. Whenever you are given a question on atoms, how many protons, electron, neutron it has, which one should you look at first? Proton, electron, or neutron? I think I've said it many times. Whenever you are given a question like this, where you can count proton first. Count proton first. I have 5 protons. If you have 5 protons, you can tell which element is this. You go to the periodic table, you look for an element with proton 5. It's boron. Meaning B is wrong, D is wrong. Cannot be carbon, must be boron, because only has 5 protons. Next, then you go and count electrons, also got 5, which confirms that it's boron, right? It's a boron atom. Then you look at the neutron. How many neutrons do you have? You go and count. Okay. 1, 2, 3, 4, 5, 6, 7. 7 neutrons. So if you add up 5 plus 7 is 12. Meaning the mass number is 12. Answer is C. Okay? Can? Now next, let's move on to question 38. Which substance is polyunsaturated? A polyunsaturated. Polyunsaturated means it has more than one carbon-carbon double bond. So just now we went through alkenes. Alkenes have a carbon-carbon double bond. But if it's polyunsaturated, means you have more than one carbon-carbon double bond. Many students will choose polyethene, but the answer is wrong. Polyethene has no carbon-carbon double bonds. We went through this before, right? Polymers don't have the double bond anymore. The monomer has a double bond already open already. So the polymer don't have double bonds. The answer is D. Vegetable oil is polyunsaturated. Okay, the NFS students should know this well. Vegetable oil contains unsaturated fats. That's why it's healthier for patients with high blood pressure or heart disease. So vegetable oil is polyunsaturated. The opposite of vegetable oil is animal fats. Animal fats like butter. Butter is saturated. That's why butter is also unhealthy, okay, for patients who have high blood pressure or heart problems. Question 39. Which change cannot be achieved by a single reaction? Answer is B. You cannot increase from 2 carbon to 3 carbon. 2 carbon to 3 carbon, not possible. Using a single step, a single reaction. Cannot. Okay, you have not learned any reaction like this. So ethanol got 2 carbons, propanol got 3 carbons, not possible. Okay. Now, most students in 2013 thought that the answer for question 39 was D. Glucose to ethanol and CO2. This is possible. This is fermentation. Fermentation is a single reaction that converts glucose solution to ethanol and carbon dioxide. So it's possible. Okay, so let's not forget about fermentation. Okay, and with that, let's go to the final question, question 40. Very poorly done as well in 2013. Okay, how do I know it's poorly done? Because the examiners said so. Now, when you add bromine water, it turns colorless. It decolorizes aqueous bromine. That means it must have carbon-carbon double bond. Right? Only things like alkenes with a carbon-carbon double bond can decolorize aqueous bromine. Next, you add aqueous sodium carbonate. You form carbon dioxide. Means it must be acidic. From the perspective of organic chem, acidic means carboxylic acid. So you must have both carbon-carbon double bond and COOH. The answer is D. Okay, so please realize that organic compounds can have more than one functional group. In this case, it has both the double bond between carbon as well as COOH. Okay, so it has two functional groups in the same molecule. Okay, it doesn't need to have just one functional group. In this case, based on the evidence from the experiments, you have two functional groups. Okay, so with that, we have finished going through 2013 TYS. So let me just stop the recording here.